Okay, now that we have talked about complex fractions, we're going to talk about them with variables. So this is getting the algebra involved. We still are going to use the same concept. I'm going to use method 2 only because I find it more efficient. And it's also going to get us ready for clearing fractions. Because the idea is if you don't have to have a fraction, wouldn't you want to get rid of it? You all agree on that, don't you? Oh, I see a lot of head nods. Yes. They want to get rid of the fractions, everyone. They do. They really do. Okay. If I look at these two, I have fractions here. What's the denominator on the 4? It's a 1. Okay. What is the first thing we're going to do, step 1, is we're going to determine the LCD. Okay. It's going to be x minus 1, I hear, and x minus 2, because this is not 1 and 2. This is a number minus 1 and a number minus 2. Once I have figured out the LCD, then I can multiply the numerator and denominator by that LCD. And I saw some of you do it this way. X minus 1 times x minus 2, and then over here, x minus 1 times x minus 2. I'm multiplying that in the numerator. That's basically the idea of distributing it. Right? I have to multiply it to both terms. So I'm going to do the same thing here. X minus 1 times x minus 2. I'm going to multiply this term by that. And then over here, x minus 1, x minus 2. So we're multiplying every single term. This is one fraction, and this is another fraction. You can think of it that way. And then here, again, you're multiplying this by that LCD and this one by that LCD. Okay, so now we're looking for how we could simplify. Can't I do a little cross cancel here because I'm multiplying everything? So then I have, and I'm going to go on to the next line, I have 2 times x minus 2. That's what's left when I multiply by the LCD. Here, does the 1 cancel into either one of the LCDs? No. So I have minus 4 times x minus 1, x minus 2. And you're kind of groaning right now because you're probably like, oh, that's going to be a lot to multiply, isn't it? That's okay. At least we don't have fractions anymore. Look at the bright side of things, okay? Now, on the denominator side, the x minus 1s cancel, right? And what's left? Well, x minus 2 times 1. So we have x minus 2. And then here, the x minus 2 cancels, and we have plus, because of the plus sign, 1 times x minus 1. Now, some of you might think that right now you could just cancel these out. But why can't you cancel those x minus 2s? See, what I did was I got rid of the denominators. Yeah, because of the subtraction here and addition, we have to simplify. So right now, step 2 is going to, well, step 1 was we cleared the fractions, clear fractions, using the LCD. Well, that was really step 2, I guess. We found the LCD, step 1. Step 2, we cleared the fractions, okay, with an S. Step 3, what do we need to do now with this? Simplify the numerator and denominator. Okay? Denominator. Oops. Okay, so here to simplify, I have to distribute. So I get 2x minus 4. I would really need to FOIL that whole thing out. Minus 4 times x squared. That outside would be negative 2, positive or negative 1. That's negative 3x is my middle term. And then last, negative 1 times negative 2 is positive 2. So I FOILed that, by the way. I haven't added anything. I've only just multiplied. I'm distributing here, and then I'm distributing here because I'm subtracting the 4 times that whole binomial. Or binomial times a binomial, right? So I FOILed that out. If I want to keep going, I'm gonna do the denominator, and then we're gonna keep simplifying. So what could combine in the denominator? Do I have to distribute anything? No. So I have x plus x is what? 2x, right? Because we're adding, right? Negative 1 and plus negative 2. Oops. Negative 3. Okay, and we keep simplifying. So in my numerator, I actually have to distribute the negative 4 to all of these. So I have 2x minus 4 minus 4x squared plus 12x. And what would be my last term? Minus 8. Good. Over 2x minus 3. I still can't cancel anything because I don't have my numerator fully simplified yet. Okay, so we're still simplifying. So now here I want to combine my like terms. Combine like terms. Okay, so what are the like terms that I can add together? Yeah, and how many x's is that? 14x. Okay, I'm going to start with my x squared. That's going to go first. Negative 4x squared plus 14x because you have 2x and 12x. And then you have negative 4 and negative 8. What's that? Negative 12. Over 2x minus 3. And you see why we need a lot of paper for these. I'm going to have to go on to more paper. So I'm going to get out some scrap paper here. What do you think we should do next? Any thoughts? Well, we want to try and see if we can simplify, right? In order to simplify, I would need to factor. I would need to factor, yes. Okay, if I want to factor the numerator, what would I need to start with? Always the GCF. What's the GCF here? Oh, it starts with a negative, so factor out a negative. Does 4 go into 14 though? So we have to go a little smaller. So that's going to be negative 2. If I factor out a negative 2, I get 2x squared minus 7x plus what? 6 over 2x minus 3. Can I cancel these 2's? Say no. Please say no. Please say no. You cannot cancel those 2's because that's not factored, right? This is a binomial, so if you want, you can put it in parentheses. We're probably going to have to use what method to try and factor this? AC method. Okay, 2 times 6 is 12. Can you give me 2 numbers that multiply to 12 that add to negative 7? Negative 5 and negative 2 multiply. Oh, is that right? Oh. Negative 4 and negative 3. Okay, add to negative 7. And so let me just over here go ahead and factor it. Minus 4x minus 3x plus 6. So I'm just reviewing a little bit of factor by grouping, right? AC method. What's the greatest common factor here? And we get x minus 2. What's the greatest common factor here? X minus 2. And then that's equal to 2x minus 3 over x minus 2. So we have negative 2 times 2x minus 3, x minus 2, all over 2x minus 3. Now, a lot of times that denominator is almost like a hint at what might possibly cancel. It doesn't always work out that way, but in this case it really did, didn't it? Okay, so what would reduce? So we end up getting negative 2 times x minus 2, but x cannot equal what number? Since we canceled out that 2x minus 3, what number would give you 0 there? That's a little bit tricky. Yeah, so you could set it equal to 0, add 3, 2x equals 3, and then divide by 2. X cannot equal 3 halves, because if we plugged in 3 halves here, we would end up getting 0. So that was the 3 halves, if I solved that. So if you're not sure, if it's not obvious what number You see that what we call that is retaining the restriction on the domain. And now I covered up some of my work. This was a really long problem. Was there anything else that originally canceled that we would also need to retain as a restriction on the domain? So in the end, that one canceled. But if we go back to the beginning, what other restrictions on the domain ended up canceling out? So I'm going back to the beginning of the problem. And then I'll carry this one over here. Yes, so 2 and 1 would have been restrictions on the original domain, and they canceled out. So that would be more restriction. So you have x cannot equal 3 halves, and from the beginning you have x cannot equal 1 and x cannot equal 2. But I guess that's not in the denominator anymore. So that did cancel out. That would have been a restriction on the domain of the original problem, which is all x'd out now. You can't even read it. But any thoughts or questions on this? This was the exact same process you did for method 2. It's just now with variables in it. So thinking about clearing the fractions so that it's easier to simplify, and then WebWork will want all these restrictions on the domain. Okay? Because you don't even have a fraction anymore. Right now, just this problem right here, because it's over 1, that has no restriction on the domain. But the original problem had all those places where different values of x would give you 0. And those disappeared. So we have to retain that. Okay? Any thoughts or questions before I end this one? All right.